The basic exponent laws, we start by writing something like this. Now, you're welcome to use a base like 2, or you could write a 3, or you could even write like just the variable a. But what we're going to do is we're going to notice a pattern. So it's fine if you use the number for noticing this particular pattern. And the deal here is 2 is 2, 4, 2 to the third, 2 times 2 times 2 is 8, and then 2 to the fourth is 16. To continue the pattern on the left, we have 2 to the fourth, 2 to the third, 2 to the second, 2 to the first. So then we'll have 2 to the 0, 2 to the negative first, 2 to the negative third, and maybe up to 2 to the negative fourth. Then the deal is, like to notice what happens when you move up. So from 2 to 4, and from 4 to 8, and from 4 to 16. Each time what you do is you end up multiplying by 2. So then to go down, what you end up having to do each time is divide by 2. So if we start at 2 by 2, 2 divided by 2 is 1. And this is actually same story when you deal with 3. Well, 3 to the first is 3. Now to go up, you multiply by 3. To go down, you divide by 3. You get 3 to the 0 is equal to 1. So from this row here and from this row here, the general story, same deal. You'll get 4 is 1, 5 is 1. The pattern to notice about this is that a to the 0. So we'll write that here. Because 0 is equal to 1. Again, the game we're playing here is actually pattern recognition. Um, so from this, so from this row right here, this 2 to the 0 equals 1, we'll get our general formula here, that 8 to the 0 equals 1. That's not all though. We'll continue dividing by 2, and if you did 1 divided by 2 off to the side, well, that'll just be 1/2. Let's not overthink that one. The next one's a bit more work, but if you do 1/2, then again to go down, 1 by 2. So 1/2 by 2, if you do 1/2 divided by 2 over 1, or times circle 1. Across you get 1/4, and in the same way you get 1/8. And I should have mentioned earlier, but from this row, 2 to the negative first is equal to 1/2. You actually get this general formula, which is that 8 to the negative first is equal to 1 over a. And then finally, it's from rows like here where you can actually notice 1/8 or 1 over 8 is, I already wrote the 1 over. Now the 8 in the denominator, I'm going to instead rewrite 2 to the third. Sorry, this is small. So we'll have 1 over 8 equals 1 over 2 to the third, and then same deal with 1 over 16. This is 1 over 2 to the fourth. If I then bring up these formulas, and move them a little closer, then, then there we go. Yeah, we'll do that. Erase these. Then there's a general pattern to notice from these rows, and if we continue down this way, we notice the pattern as well. And it's actually even helpful to look up here to see what kind of numbers we're getting. And the idea is that a to the negative nth is equal to 1. So these three formulas right here, a to the 0 is equal to 1, a to the negative 1 equals 1 over a, and then finally a to the negative n equals 1 over a to the no more minus sign. So 1 over a to the n. These three formulas are really built by writing down a table that looks like this. And following the pattern, again, you see the pattern over here on the left is to lower the exponent by 1 each time you move down a step. And then here the pattern is when you go up a step, you multiply by 2 each time, at least if you have base 2. And then to go down a step, you divide by 2 each time. And so then we notice patterns like this that are this way.